Hello guys, welcome back to Manala's Arc. This video that I'm doing now, I'm creating it for the grade 10s and grade 11s. So which means this question that I'm about to show you now, it can appear on a grade 10 paper and it can appear on a grade 11 paper. So I hope you all will be able to watch this video. And I'm actually expecting both of you to be able to solve this question, right? So here's one question that I took from one of the past papers. I don't want to tell you it's a past paper from which grade, because if I say grade 11, the grade 10s are going to think that this is way too difficult for them, and therefore they're going to think it's okay for them to lose marks on this one. And then if I say I took this from a grade 10 paper, then the grade 11s might say, oh, well, probably this is too easy. Maybe I don't need to do it. More or less something like that. So now, let's just do this. Both of us. Oops, I made a mistake there. Let me fix that. Yeah. So let us both of us do that and see if we can win here. So the question says, the diagram below shows a spotlight at point B, which is moved 12 meters directly above point C. Here it is right here. And it says, at the front of the field. Okay, yeah, that's what it has made. The spotlight swings 43 degrees. Here it is that 43 degrees where it swings from the vertical to illuminate another point at D. Here's the point at D, the midpoint of AC. And you can see by the markings that D is the midpoint of AC. Then they're saying 7.1. Calculate the length of DC for 3 marks. Now guys, I don't think you need me to tell you that this will be an easy question for both grades if you ever get a question like this one. So this will be where you copy your 3 marks here. So if ever you need to do that, you are looking at DC in relation to the angle, the one that is 44.3 degrees. Let me switch off my phone. Calls keep on coming through. You see them? Okay. Now, here, if you have to put that in writing in that sense, this angle, it's opposite to the side we are looking for. So we need to use a trig function that can help us use this angle, this side that is adjacent, and the side that is opposite, right? Which trig function allows us to use the opposite side and the adjacent side? If you guessed it right, this will be the tangent, right? This is the tangent of 44.3 degrees. Now this tangent, it's equal to what? Opposite over adjacent. What is opposite to that angle? What is opposite to that angle? It's DC. What is adjacent to that angle? It's that 12 meters there. So now we have to solve for DC. Now if we solve for DC, we have to multiply both sides with 12, right? This is 3 here. So DC over 12, we are going to multiply this side with, put that there. Going to multiply this side by 12, and we will also multiply this side by 12 so that this ones can cancel through. Therefore, this gives us something like DC is equals to, on my calculator, it gives me 11.71. And we were measuring distance in what? In meters. So the unit, the length of DC, it's 11.71 meters. See how easy is that? For 3 marks, definitely you'll do that in less than 3 minutes. Definitely. So now 7.2, it says, let me read it with you. Calculate through how many degrees the spotlight must swing. This is the spotlight swinging from this point here. Calculate how many degrees the spotlight must swing in order to illuminate the point at A. So when it swings here, the angle here, that's how many degrees. The angle here, that's how many degrees it will take for this light to illuminate the point here. So this angle combined with this angle, that's how many degrees it will take for that to happen. Now that is interesting now, because we already have the side DC, and if we have DC, then this warrants us the side AD, and if we have DC being equals to AD, then we can find out what is AC. Let's start there. How much is AC? AC is equals to twice this distance, and that is 23.42 on my calculator. Meters, right? So now, with that being said, Since I have this side, now I have to find out a trig function that will help me use the side AC and the side BC. Oops. Sorry guys, I was converting a video there and then now it's done. So I'll get back to it when I'm done here. So yeah. Now the side AC. What was I saying? We need, put this in. We need to focus on a trig function that will allow us to use this side and this side in reference to this angle here. And bear in mind, this angle, it's not the angle of depression. The angle of depression is always attached to the imaginary x-axis, to the x-axis, let me say so. So this one, we can call it the angle of elevation, and this one also can be called the angle of elevation, because these ones are measured from the x-axis. Okay, let's move on. So a trig function that will allow me to use this 12 centimeters from BC and this 23.42 meters from AC. It's tangent. I'm sure you all guessed that. So now we are saying this is the tangent of what? This is the tangent of the angle B. We good? So the tangent of angle B is equals to what's opposite to B, that is AC, over what is adjacent to that angle, that is BC. Now substitution, I'm saying now the tangent of B is equals to 23.42 all over 12, right? And now when I have to solve for that, I'll have to take tangent to the other side, which I'll take it to the other side by the arctangent, this way. We are saying it's the arctangent due to this thing there, right? And this will land me where? This lands me now at 62.87 degrees. Now, you might think that you've answered this question. Let me drop this phone. You might think that you have answered this question, but you haven't. Because what you found instead, you actually found the angle B, the whole of angle B. What we are looking for, it's the theta there. Now, this theta here, to find it, you must remove this part from the whole angle of B, and then the remaining is your theta. Let me create some space for that. So here's a small gap above there. I've erased the details whereby we can do that. So we are saying now theta is equals to the angle B minus the 44.3 degrees. Substitution to that, my B was 62.87 degrees. If I subtract 44.3 degrees, then my theta will be 18.57 degrees. Don't forget the unit there. So that's as easy as that, guys. I hope that is okay with you, and I hope you were able to solve this. I hope you actually paused the video to attempt the questions on your own before you watch the whole video. Now, with that being said, don't forget to like the video and share it to anyone who you think it might help. And that is all from me for now, and I'll see you on the next video. Goodbye.